Okay, so let's get started with Lab 1, and we're going to get introduced to the MPLabX IDE. I've opened MPLabX on the PC here. It's built on the NetBeans IDE, and there's a lot of code in here. We'll start off and we'll open the file, and we'll open a project, and MPLabX goes to a default folder called MPLabX projects in your user directory. So what we're going to do is copy the course material over to that directory. So here I have the unzipped contents of the course materials, and you see we have code, modules, and reference materials. So the course modules, PowerPoints, and so forth are here. Code has 3 subdirectories. One is for IoT Creator, one is for FreeRTOS applications, and finally the third is MPLabX projects. This is the one that we're going to use. We can select all of the projects here, copy them, and then we're going to switch and put them into this directory, the MPLabX projects, for your user. So here is that directory, and we will paste those projects in to install them. Now that we've done that, we can go ahead and open Project 1, Lab 1 Introduction. We will open that. And here we have a project window which shows us the contents of the lab with source files. So here are the .c files and the header files, system.h and user.h. Those are the main files we will be working with. So if we look at Lab 1, with the instructions, we can step through those. And that's what we're going to be doing here. One of the first things to do is to connect the hardware. So we have the chip kit board, and we have a debug connection right here. So these headers here, this header with these staggered pins, is where we're going to connect the debugger. So we're going to use this PicKit3 debugger, and that connects by USB to the PC. And here you can see we have a connector, 6-pin connector, with pin 1 marked with the arrow. And here, the top pin is pin 1. So we want those to line up with each other. So here I've got a flat 6-pin cable. I've got a right angle connector, and I will insert this into this header. We could also plug it in from the back of the board if we have a basic I/O shield or some other shield on top of this board, limiting our access here. But you can see that with the angle here, we go over the Wi-Fi module, and connections go in there. So now we can connect this end, again with pin 1 connected to pin 1, so the red goes up where the arrow is, so that the pins are consistently connected with pin 1 here, pin 1 here. And now we can see about plugging in these boards to the PC. So the Wi-Fi board will plug into this USB connector here, the USB connector that's labeled UART. We plug that into a PC, USB port, and Windows recognizes it and installs the device driver software. And after that, we're going to install the software, or we're going to plug in the PicKit3 debugger. So we have another USB cable from the PC that goes into the debugger, and plug that in, and the software, Windows recognizes that. Now we can take a look at our project and take a look at the dashboard for the project. So here we have project options, and what we want to do first is make sure that our debugger is connected. So let's look at the source code for this project. So with step 10, we've gone ahead and expanded the source file description, and on step 11 we're going to open main.c. We can select that, and the source code will open up in this code editor window, and we can see what is in our program. So here we have the main function, which calls a init app and then calls flash LED. So we're going to take a look at the user.c file, which holds these functions. And here we see init app, which has the C source code for initializing peripheral pins. So we have statements for configuring an I/O bit to be an output to turn on the LED. In this case, we turn it off, and also configuring an I/O to be an input to read a switch. So that's the init app function, and we have our flash LED function. And in this case, all we're doing is turning the LED on and then off in an infinite loop. You'll notice now that we have an additional tab up here. We have user.c as well as main.c. We're going to go through several versions of this flash LED function, and we're going to start off with version 1. So here we have our #define ver1 so that this code will execute. Our Wi-Fi board has 4 LEDs, LED 1 through 4, and we're going to be lighting those up. And our code is going to start off by just flashing one of the LEDs. In order to proceed, we need to configure the project to recognize our debugger. So the Picket3 debug interface needs to be recognized. So looking at step 20, we're going to look at the project options, the project properties. So we click that, and you can see we have several options. Which hardware tool we want to use for debugging. So we see the Picket3 debugger located here, and we also see which compiler tool chain we're using. If you have installed a newer tool chain, you'll want to select that one. And we also see the device, the microcontroller device that's used. On the left here, we see there are several configurations. We have 2 configurations in this example. We have the first, which targets a PIC32 EC. This is the Wi-Fi revision B. This configuration, the EF, targets the Wi-Fi board revision C. So we're using revision C here, so we want to make sure that we use this configuration. We make sure that the device for the configuration matches the microcontroller on the Wi-Fi board, which is the EF for the revision C board. So we can click Apply, and up here we have a drop-down box that shows different configurations to select from. So here we see there's the EC version, that's the revision B, and the EF version, the revision C. So we want that EF version, so we make sure that's selected. And now we can go ahead and build our project using either the hammer icon or the hammer and broom icon. This is a clean and build. So the clean deletes temporary files first and deletes output files, and then rebuilds the project. So we can build that, and the tool chain will tell us what it's doing as it proceeds with compiling the separate files and then linking the executable from those object files. So we have a successful build here. Next, we can download the program to the board, and we use this Make and Program Device icon. And we get a status window here that shows us the compiler tries to rebuild the program to make sure it's up to date, and then it connects to the Picket3 debugger and determines which microcontroller it's talking to, and then erases it, and then starts programming it. We see the boot config memory, the configuration memory were both programmed. All the code was programmed and verified. And here we can see the LED. LED 1 is lit. And it's actually flashing, but it's flashing so quickly we can't see it. So we're going to modify the code to make it flash more slowly. We're going to go to step 29. And in that code, in that step, we switch from version 1 here in user.c to version 2. And nice thing about this development environment is that it grays out code that is not going to be included by the preprocessor. So this if vir equals 1 section here of code, vir is not equal to 1 anymore. Now it's going to be equal to 2. So this code is grayed out, and it tells you that code's not active. Similarly, we have more version code down here. That's going to be grayed out as well. So here's our code. We have our infinite loop. We turn on the LED, and then we have a delay. And this is just a simple delay loop. And then we turn off the LED, we have another delay. So we can rebuild this using either build project or clean and build. Either will work. And that's successful. And now we can download the code. The Picket3 status LED is flashing red-green. And then finally it finishes green, indicating it's done. And over here we can see the Wi-Fi board is flashing LED 1. Our program is running. So that's good, that worked. Now let's take a look at controlling the speed of the LED flashing by reading a switch. So this is step 34 in the lab. The Wi-Fi board has 2 push-button switches here. We can read them by reading the port bits. So let's take a look at the user.c file. We're going to change this to version 3, and that will enable this code down here, which is going to run an infinite loop. And the first step is to check to see if the switch is pressed. If this bit is a 1, then the switch is pressed, so we're going to set the delay count to 1 value. If the switch is not pressed, we'll set the delay count to a different value. And then we toggle the LED. We turn it on, we wait, we turn it off, we wait, and then we repeat it. So we can rebuild this, and then we can download it, and we'll see the debugger colors changing there. And now we can see the LED flashing again. If we press this switch, it flashes faster. If we release it, it flashes slower. And be careful when pressing this switch because there is a pin sticking up, a ground reference test point. So you don't want to hurt yourself with that while you're pressing the switch. That shows how we can download code after building it to the board and run it. Lab 2 shows how to use the debugger. We can download the code for debugging on the target hardware, but we're not going to do that in this lab. So now we're done. So you can exit the project and disconnect the hardware and wrap that up.